All right, today we have Keeper 4.9, derivatives of inverse functions. So the first thing we want to talk about is the derivatives of inverse trig functions. So like sine inverse, cosine inverse, tan inverse. All of your formulas for your inverse trig functions are given here. These formulas do need to be memorized, and you probably want to cut them out and put them into your Keeper. And you want to memorize them, so maybe make some flashcards or something like that to remember your derivatives of inverses. Now, the quick, easy way to do it, or one of the little tricks I use, is that if you notice, the derivative of sine inverse is the exact same as the derivative of cosine inverse, except for cosine is negative. And we talked about that. Anytime you see the derivative of like something that starts with C, we know we're going to put a negative in front of it. And then you'll also notice that like tan and cotan are exactly the same, except for cotan has the negative, and then the same for secant and cosecant. They're exactly the same, except for cosecant has the negative, which really means you only have to memorize 3 of these, and I would memorize like this, the sine, the tan, and the secant, and just remember if you do cosine or cosecant or cotan, you just put the negative in front. All right, so let's look at an example. We have y equals tan inverse of 2x. And so what I'm going to do is I'm just going to throw this into my formula. So my formula says that I have 1 over 1 plus whatever was inside of that tan, in this case 2x squared. Now the catch is you actually have to chain rule this. So I also have to take the derivative of 2x. And at this point, you guys should know that the derivative of 2x is 2. So I'm going to do my formula, and then I'm going to times that by 2 because that's the derivative of 2x. And from there, I just clean it up, make it look pretty. So simplifying, I'd make that 2 over 1 over, or 1 plus 4x squared. Okay, so next we have y equals sine inverse of x squared. Again, all I'm going to do is take that x squared and plug it into the formula for sine inverse. So when I do that, I get y prime, or the derivative, equals 1 over the square root of 1 minus x squared squared. Now again, remember I have to chain rule this, so I have to take the derivative of x squared, which in this case is 2x. And from there, again, I just clean it up, make it look pretty. So I get y prime equals 2x over 1 square root of 1 minus x to the 4th. Next, we have y equals secant inverse of x cubed. Just like I did before, I'm going to take that and I'm going to throw that into my secant inverse formula. And so I get 1 over the absolute value of x cubed times the square root of x cubed squared minus 1. And again, I got to multiply that by the derivative of that x cubed, which is 3x squared. From there, I'm going to simplify it, make it look nice. So I get 3x squared over absolute value of x cubed times the square root of x cubed squared minus 1. Cleaning that up, making it look even better, I would get 3 over the absolute value of x if I reduce out the x squareds, times the square root of x cubed squared, or x to the 6, I could have written it either way, minus 1. Next, we want to look at the derivative of inverse functions. So not necessarily trig functions, but inverses in general. So the derivative of f inverse of some expression b is equal to 1 over f prime f inverse of b. All right, so in this example, we have f of 4 equals 5, and then they told us that f prime of 4 is 2/3, and they want us to find the derivative of the inverse at 5. So again, all I'm going to do is use my formula that I have memorized, and I'm going to plug in my 5, or the value of whatever x is, into my formula. So the derivative of f inverse is equal to 1 over f prime f inverse of 5. Now looking at this, making sure I'm doing my composition properly, I need to start by finding out what f inverse of 5 is. And so once I figure out what f inverse of 5 is, then I'm going to take that derivative. Well, in the problem, they told us that f inverse of 5 is 4, because if you remember, with inverses, this is actually your y value. So this 5 is your y value, which is this 5 up here. And so the inverse of that would just simply be 4. And so I would end up with 1 over f prime of 4. Well, they told us that f prime of 4 was 2/3. Again, in the problem, in the initial problem, they told us f prime of 4 was 2/3. And so if I take that 2/3 and plug it in, I get 1 over 2/3. We don't usually keep double fractions, so I would just clean that up by multiplying by the reciprocal, and so my final answer would be 3/2. All right, last example, we have f inverse prime of 3. Again, I'm just going to use my formula and plug that 3 into my formula. So I have f prime f inverse of 3. I'm going to start by finding the inside piece, which is my f inverse of 3. And so I'm going to look for a y value on f of 3 and see what x value that corresponds to. And so the y value of 3 corresponds to the x value of 2. So I'm left with 1 over f prime of 2. So then at f prime of 2, so when x is 2, the derivative they told us is 4. So I'm going to end up with 1 over 4.